Before you've finished your morning coffee, you've probably interacted with a data center dozens of times. Your alarm synced with the cloud. Your weather app downloaded the forecast. Your bank account updated overnight transactions. Emails arrived. Music streamed. Social media feeds refreshed. Each action feels instant. But behind every click, swipe, search, and stream is a network of computers housed in buildings that most people never see and rarely think about. At its simplest, a data center is a facility that houses computer servers. But a better comparison might be a modern library. Instead of storing books, data centers store, process, and distribute information. Every photo saved to the cloud, every online purchase, every streaming movie, every business transaction, every medical record, all of it relies on data centers operating around the clock. The importance of these facilities becomes clearer when you imagine a world without them. Hospitals rely on data centers to access patient records. Emergency responders depend on digital communications. Businesses use them to process transactions. Governments rely on them to deliver services and safeguard information. In many ways, data centers have become just as essential to modern society as highways, power plants, and water systems. For decades, demand for computing power has continued to grow. From mainframe computers to personal computers, from the internet to cloud computing, each technological revolution required more infrastructure. Today, artificial intelligence is driving the next wave of growth. Every AI-powered search, recommendation engine, image generator, and chatbot depends on powerful data centers working behind the scenes. But AI is also transforming industries far beyond consumer applications. Pharmaceutical companies are using AI to accelerate drug discovery. Financial institutions are deploying it to detect fraud and manage risk. Healthcare providers are exploring AI-assisted diagnostics. And businesses across the economy are using it to analyze data, automate processes, and improve decision-making. As AI adoption expands, data centers are increasingly viewed as foundational infrastructure for future economic growth. But AI creates a challenge that few people ever think about. Modern AI processors generate significantly more heat than traditional computing equipment. As computing power increases, so does the challenge of keeping these systems cool. For years, most data centers relied on traditional air cooling. Cold air moved through server rooms, while hot air was pushed away. As computing demands increased, operators adopted chilled water systems and evaporative cooling technologies to improve efficiency. But the AI era is forcing the industry to rethink cooling altogether. Today, some of the most advanced facilities use direct-to-chip liquid cooling, sending coolant directly to the hottest processors. Others are adopting closed-loop systems that continuously recycle cooling fluid while minimizing water consumption. Some operators are even experimenting with immersion cooling, where entire servers are submerged in specialized non-conductive liquids. As AI continues to grow, cooling technology may become just as important as the processors themselves. These national conversations are now playing out right here in New Jersey. In Kenilworth, an artificial intelligence cloud computing company plans to redevelop a former pharmaceutical research facility into a modern data center. As with many data center projects across the country, residents have raised questions about noise, energy demand, water use, and quality of life. According to an independent acoustic study, normal operations are expected to generate between 42 and 49 decibels, roughly comparable to the sound of a household refrigerator. The study also found that existing background noise from the nearby Garden State Parkway is already higher than the projected operational noise levels. Questions about energy demand are also common. The project includes approximately $150 million in funding for a new electrical substation intended to increase capacity for both the facility and the broader local grid. Water use has become another major topic in data center development. The facility is expected to use a closed-loop cooling system designed to minimize ongoing water consumption. After an initial startup phase, cooling fluid continuously circulates through the system, reducing the need for significant ongoing water use. Construction activity will bring temporary increases in traffic and site activity. However, once operational, data centers typically employ smaller workforces and generate less daily traffic than many industrial or commercial facilities. As more facilities are proposed nationwide, communities are weighing important questions about energy consumption, water use, land development, and environmental impact. At the same time, nearly every digital service people use every day depends on this infrastructure. The challenge facing communities, policymakers, and industry leaders is finding the right balance between supporting technological growth and addressing legitimate local concerns. As artificial intelligence continues to reshape the economy, demand for computing power will continue to grow. That means the buildings behind our digital lives, the data centers that quietly power communication, commerce, healthcare, transportation, and countless other services, will become increasingly important. The next time a text message arrives, a bank balance updates, a favorite show begins streaming, or an AI assistant answers a question, it's worth remembering that none of it happens by accident. Behind every click, swipe, search, and prompt is a vast network of infrastructure working quietly in the background. Most people may never visit a data center, but they rely on one every day.